We have two precise rulebooks for how the universe works. The problem is, when applied together, they clash and break down. The first is general relativity. Einstein's description of gravity treats space and time as a smooth fabric, predicting the deterministic paths of stars and planets. The second is quantum mechanics. It governs the subatomic world, operating on chaotic probabilities and sudden jumps. For a century, physicists have struggled to merge these frameworks, but combining the math of gravity with the math of particles consistently results in equations that break down into infinities. Decades have been spent searching for hidden dimensions or loops of space to bridge the two, but these models omitted the researcher, the person performing the measurement, from the equations entirely. A new framework, the observer-dependent theory of everything, or ODTOE, changes that by treating the observer as a mathematical variable. Its central axiom is that reality is a constructive act, R equals O of psi. An observer interacts with a field of potential states, collapsing a specific segment into a measurable, solid structure. This represents a structural mechanism. The observer's dimensionality and state of belief dictate which version of reality emerges from the infinite possibilities. In this view, quantum mechanics and general relativity describe the same underlying reality, just viewed under different conditions of observation. We map these theories on a periodic table. The vertical axis, dimensionality, measures the observer's scale. At the absolute bottom, the Planck scale, tiny actualized fragments form string theory and loop quantum gravity. The middle rows represent biological observers, governed by the Standard Model and chemistry. Dimensionality explains the scale of what we perceive, but it doesn't explain why the laws of physics shift from chaotic to deterministic. That shift is governed by the horizontal axis, S, or coherence. This represents the degree of synchronization between multiple observers. On the left is the low coherence zone. When observers are desynchronized, reality behaves like a roll of the dice, full of branching stochastic noise. We know this environment of uncertainty as quantum mechanics. Moving right, we reach the high coherence limit. Massive clusters of observers perfectly synchronize, suppressing noise into smooth, predictable geometry. This state of total observer agreement is the world of general relativity. Equation 10.1 shows this mathematically. The noise term, eta, is tied to coherence. As S reaches 1, the noise vanishes, leaving a deterministic equation. The gap between quantum particles and gravity is a function of observer coherence. No new particles are required for unification. The transition is continuous. This unified map changes how we define our place in the cosmos. It creates what is known as a strange loop. The observer emerges from the potential field, only to define the very field that created them. An observer's cognitive coherence, their state of belief, is a quantifiable metric. It directly influences the mathematical probability of a physical outcome. Physics can no longer treat the universe as something separate from us. Unification proves that reality is a mathematically precise dialogue between the watcher and the watched.